I'm so glad to be here, and I'm excited that you all stayed through the end, and I hope that this will be worth your while. So I'm here today to talk to you about SRE and the art of SLOs. My name is Nathen Harvey. I'm a developer advocate at Google Cloud. You can follow me on Twitter if you like. There's my Twitter handle, and my preferred pronouns are he or him. So when we think about SRE, there are a couple of key principles that really drive all of the philosophy and thinking around site reliability engineering. The first one is that the most important feature of any system is its reliability. I want you to just think about that for a second, because I think this can sometimes be a little bit contentious. The most important feature of any system is its reliability. Can you think of other features that might be more important than reliability? What's that? Security. Maybe security is a component of reliability. Maybe it's not. I don't know. Maybe security is more important. What else? The capabilities of your application, right? So yes, capabilities are certainly important, but with an SRE approach, we would say that the capabilities that you build that aren't available, who cares, right? So reliability. This is the thing that is the most important part of any system. I think it's fair to have a debate around whether or not this is true, but I think it is important that we understand that SRE comes from this framework or from this mindset. The second principle for SRE, or for site reliability engineering, is this: our monitoring does not decide our reliability. Our users do. Now, I know you've never been in this situation, but let me share a story from my past. It's a Saturday afternoon. Everything's going well. I'm the person on call. I'm out with my family, and I get a phone call from the VP. Hey, the CEO just called. Something's wrong. I said, okay, well, I'm on call. Let me just pull up. Nope, everything in Nagios is green. CEO's wrong. Everything's fine. Guess what? Everything wasn't fine. We definitely had some issues with the reliability of our service at that time. But all of my monitors were green, so I was moving along the world very, very happy. I know, as I mentioned at the beginning of that story, none of you have ever been in that position, so I feel it's important that I share that. Sometimes it happens. And then the next thing, the third principle that SREs think about is this. What we need in order to have good reliability within our systems, it starts with well-engineered software. We have to build and engineer applications and infrastructure that is reliable. But the truth is that's only a start of it. In addition to well-engineered software, we also have to have well-engineered operations. We have to think about, after we've built that software, after we've built that infrastructure, how are we operating it? But again, that's not even enough. The third piece that we need for this principle is we need a well-engineered business. And we've heard about this over the past 2 days. We've heard about blameless postmortems and learning from incidents. We've heard about cutting down on burnout and treating our people humanely. All of that has to do with the business. So these are the principles that SRE is founded on. And it always comes back to this question of, how do we incentivize reliability? How do we incentivize reliability? And you might ask yourself, or be thinking to yourself right now, what is it that prevents reliability or that causes reliability issues for us? How many of you will admit to having some technical debt within the applications that are running right now in production? Okay, now, if your hand is up now, you can put it down. Everyone who didn't have their hand up, you can put your hand up and say, I'm a liar. There is technical debt in all of our systems. How do we prioritize working on that technical debt? That technical debt likely causes issues with reliability. It likely slows us down. So DevOps itself was really founded on this idea. How do we incentivize the right behaviors across our organization? And from an SRE approach, what we need is this understanding, first, that 100% reliability is the wrong target for basically everything. Now this is weird, right? Our first fundamental principle of SRE, reliability is the most important part of any system. And now we're saying that 100% reliability is basically the wrong target for everything. Every application that you build. Now, as technical practitioners, how do you feel about that? Do you agree that that's true? Yes. Do your product owners agree that that's true? No. What do your product owners want? 110%. You're absolutely correct. A good product owner says reliability is the most important feature, and we need 110% of it. We need to be up 25 hours a day and fully accessible. But so how do we convince them? What we need is a principled way to agree on the desired reliability of a service. We have to have some way to talk about this. What does it mean for a service to be reliable? We have to agree that 100% reliability is not an achievable target. If we want to get to 100% reliability, there are a bunch of problems with getting there, not least of which is the expense. So we talked about what do we have to have engineered well? Our software, our operations, and our business. Think about the expense that it takes to go from, I don't know what reliability, let's say we're at 99.99% reliable, and we want to go from 4 nines to 100%. What is that incremental investment that we need to make? And that investment is not just in dollars, whether they be Australian or US. It is not just in infrastructure. It's in our people as well. So we need some principled way to agree on what's the desired reliability of a service. And the SRE practice that we use for that is error budgets. So an error budget is an acceptable level of unreliability, and that budget can be allocated. It's very similar to the personal budget that you have for your own personal finances. When you spend too much money, you blow through all of your budget. But we can use these error budgets to help us have these conversations, to reach agreements on this. And one of the most important things about these error budgets is it goes back to that thing where your monitors don't tell you about the reliability of your service. It's your customers that tell you about the reliability of your service. So an error budget captures the performance and availability levels that, if barely met, keep a typical customer happy. So we want to meet our reliability objectives, but we don't want to overshoot them. We don't want to be too reliable. We want to be just reliable enough to keep our customers happy. And we'll know if we've set a good error budget when we look at our customers and our customers' behavior. If our customers are happy, our error budgets are in a good place. If our customers are sad when we miss our targets, again, we know that our error budgets are in a good place. So how do we implement this? Well, we're going to have an evaluation of performance over some set window, and we'll talk about that in a minute. But this last sentence here is important. The remaining budget, whatever reliability you have left, drives prioritization of your engineering effort. So think about this. Every day when you come into work, you have some work that you can do. You maybe have some technical debt. You maybe have a new feature that you could work on. How do you prioritize that work? How do you make that choice? Well, the error budget is the thing that's going to help us understand which choice we should make. So there's this question, what are the consequences when you exhaust or overspend your error budget? So I've set some target, this is my error budget, or this is my objective that I want to meet. I'm not meeting that objective. The reliability of my system is not what's keeping my customers happy. So what are the consequences? What are we going to do? We have a number of different choices that we can make. Now, the most radical of them is we say we freeze all feature releases. The site's had reliability problems, so we have to stop all new work and focus only on that work that's going to improve reliability. Or maybe we prioritize postmortem items. Again, a story from my past that's never happened to you. We go to a postmortem, we identify some action items that will help us build reliability into the system. We implement, we identify them, time moves on, we have another incident, we have another postmortem, we identify things that will prevent and increase reliability, and it's the same things from last time. That's never happened to any of you, right? I didn't think so. That only happened I've worked in some of the worst places, I guess. I don't know. So when you're missing those reliability targets, maybe that's the time where we can prioritize those post-mortem items. The last one here is really interesting as well, SRE consultation. So I worked with one customer who said this was one of their top consequences of missing their error budgets. They required SRE consultation. What did that mean? It meant that when the development teams were going to their stand-up, an SRE came along. And a developer was talking about the design of a particular system. This design was going to make an API call. And the SRE just asked questions. Well, what's your backoff? What do you do when that API call fails? What's your retry logic look like? And just by asking these questions, it helped the developers start thinking in more operational ways about how to build reliability into those systems. And this was really fascinating because what happened then, once they got back into their budget, the SREs stopped coming to stand-ups and the developers started asking those questions of each other. So we've improved the resilience of the entire organization. Now, it's not all bad though, because yes, it's terrible when we overspend our budget, but what happens when you have extra budget left at the end of the period, right? It's like a bank error in your favor. There's more budget to spend. Well, in our world, the way that we think about this is when there's budget left, that means you're not moving fast enough. You're not experimenting enough. You're not learning enough from your systems. So this is an indicator that we need to move faster. So when we have remaining budget, we can use that budget. We can spend that budget to release new features, to make risky changes, for planned downtime, things like this. Whoa, 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 planned downtime. It was planned. That shouldn't count against our error budget, right? We planned this downtime. How many of your customers love planned downtime? Yeah. How many of your customers distinguish planned downtime versus unplanned downtime? Right. So if it's all about our customers, we can use that error budget to pay for our planned downtime. We can put that in there. And it's important to remember that we don't want to be too far over our error budget. I want you to think about this. So each month you get paid a salary. And maybe you're on a bonus plan. And all of a sudden bonuses start coming in regularly. Every month you're getting an extra bonus, an extra bonus, an extra bonus. And then what happens? You start to expect that bonus. And now November comes along and there's no bonuses. That's not good. We have reset your expectations. So when we think about our error budgets, we want to think about it the same way. If I set a budget or a target here, I don't want to consistently deliver reliability that's up here. I want to come just within that objective, maybe a little bit over, but I don't want to exceed that, because every time I exceed that, I'm resetting my customers' expectations. So how do we create these error budgets? An error budget starts with a service level indicator. A service level indicator is nothing more than a metric. It's a quantifiable measure of service reliability. And when you start thinking about your applications, the good thing is that your service level indicators are already there. They exist within your application. The bad news is you have to go and find them. You have to figure out what they are. I mentioned that every SLI is a metric, but not every metric is an SLI. So these things are all metrics. How utilized is my CPU? How much free memory do I have available on this node? Or how much disk space is available? Do your customers care about any of these things? Nope, they sure don't. They might care about the side effects of these things, but they don't care about these things in particular. So while we do need to monitor these things, these are not service level indicators. And speaking of monitoring, there's been a lot of talk about monitoring over the past 2 days. What are the right things for us to monitor? Within SRE, we talk about the 4 golden signals: latency, traffic, errors, and saturation. We should be monitoring all of these signals. We should know what's happening. But these signals are themselves not service level indicators. A service level indicator looks at the customer. Who is the customer and what are they trying to accomplish with our application? And with a typical application, what you're going to do is identify a number of different SLIs. And the only way to do this well is to understand who your customer is. And this means that as engineers, as operators, as technical practitioners, we cannot set service level indicators by ourselves. We need to include our product owners, maybe our executives, our leadership team in understanding what's important to the customer. And once we've figured out what are some of those critical user journeys, we can then start to define our SLIs. And so if you think about your application probably processes requests in a number of different patterns. Maybe there's request response. So we're running some website, a user requests the catalog, we show them all of the information in that catalog. Maybe your job is processing, like transcoding videos. A customer uploads a video, you do some transcoding on it and give them another file format back, so some data processing. Or maybe you're storing something. Maybe a customer's uploading photos. How long does it take to store those photos? Or how long does it take to retrieve those photos? So understanding these different patterns, is it a request response? Is it data processing? Is it storage? That can help us understand what are these SLIs, these service level indicators, going to be that we build on. So for a request response, we might look at availability and latency. For storage, again, we might look at throughput and latency. So we have this menu that we can select from. Now, who was here yesterday for Carmel's talk? Do you all remember that talk? Yeah? Remember, she was talking about how at Atlassian, when a user comes in, they provision, I think it was a Jira instance for that customer, right? And so thinking about how does Atlassian's customers interact with them? One of those critical user journeys was getting an environment provisioned, right? So maybe the team, maybe we all decided that the critical user journey that we're going to focus on for our first set of SLIs and SLOs is exactly that service Carmel was talking about. User comes in, they say they want a new instance. How long does it take to provision that instance? Let's build an SLI around that. So we go and we consult with the product team. Maybe we talk to customer support, the executives. What should we be targeting? And they come back, or we come up with this answer. The customer environment should be provisioned successfully. All right, we can all agree to that. The environment should be available. It should be provisioned successfully. But also, we're engineers. How do you measure that? We have to get a little bit deeper. So maybe at this point in our discussion, we can excuse the product owners and the executives while we, the technical practitioners, dig into the details. What does it mean? What does it mean to be successful? And where is that success or failure recorded? So we can start asking questions about this availability. What does it mean that the environment should be provisioned successfully? And what we'll look at is the proportion of valid requests that are served successfully. Well, what does it mean to be a valid request? Let's look at that. So maybe the way that a customer asks for a new environment is there's an HTTP post that goes to /environment/new. So this is an indication to the system, give me a new environment. So we can count all of those. Every time a customer makes one of those, we know that's an event. But how do we know if it was successful or not? What's something that we could look at, say, in our HTTP logs to know if it was successful? A response code. Response code, right. So what does it mean to be successful? What's a good HTTP response code? 200 is good, right? So 500 is better, right? Oh, that's not how it works? Only if you reroute them. What's that? Only if you reroute them? Yeah, nice. Okay, so to know that it was served successfully, we can simply look at our HTTP logs. So what does success looks like? Maybe a success is a 200 or a 300 status. So a customer posted some information to environment new, we returned a 200 result. That's great. And anytime we return a 500, we know that's not good. So now we can start to think about what is the availability of this service. We also have to think about where we're going to measure this. As you saw in Carmel's presentation yesterday, There's not just one instance that is taking in all of those customer requests. It gets distributed across a bunch of different instances in the background. And some of those instances maybe come and go. They might be ephemeral. So let's measure this at the load balancer. So this is a very easy thing that we can now immediately start to measure. We can look at every HTTP post to this particular URL. We can inspect its status code at the load balancer and figure out what is our service level. Now, of course, availability in this case isn't enough. Maybe we also are concerned about how long does it take. So I think it was Dave earlier said, hey, if a transaction takes more than 5 seconds, you lose a customer, right? So maybe there's something similar with this environment when we go and provision that environment. So what might latency look like? Of course, our executives or product owners agreed that the customer environment should be available, provisioned successfully, but it should also be provisioned quickly. So that now we can go through those same set of questions. How do we define quickly? When does the timer start and stop? So we come up with this, that the entire response should be given back within some number of milliseconds. Now, if you start to dig into this, you'll start to recognize problems. These metrics aren't perfect. So on the availability side, if we're measuring HTTP response codes at the load balancer, could we be missing some requests? We sure could. We're not measuring anything anytime a customer made a request that never made it to our load balancer. We're not capturing those. And likewise, if we're measuring latency and we're measuring that at the load balancer, think about all of the network that has to go from the load balancer back to that client. And maybe it takes a while to render that page. We're not measuring the full thing. But that's okay, especially as we're just getting started. But every SLI that you have, you should be able to turn into either a proportion or some percentage. So this is what an SLI will look like. We're going to look at all of the valid events. And so in our case, a valid event was any request to that URL. And we're going to use that as the denominator and put the good events over top of that. So let's say we had 100 requests and 90 of them returned an HTTP 200 status code. What is our percentage? It was 90 over 100. So what's our percentage? Yeah, right, 25%. Good job on that math. Way to go, team. All right, so we've hit 90%. Now, having our service level indicator is one step, but a service level indicator isn't enough. It tells us what is the current level of service. But every service needs an SLO associated with that. An SLO is a service level objective. So a service level objective is a reliability target. And because every SLI can be shown as a percentage, we know that fully reliable is 100%. We also know that that's not achievable. So we can hit 100%. We're going to back off from that. Now, how far do you back off of that? I don't know, because I don't know your customers and I don't know your business. Your product owners initially thought 110, so we've got to overachieve that. Well, we know we can't do that. Let's assume we've convinced them that we can't. What are they going to ask for? I don't know. Maybe they're going to come back and ask for 5 nines. Maybe they're going to ask for 4 nines. Here's the important bit. You have to understand, what are your customers' expectations? What makes your customers happy? If your customers are happy with 9 5s, don't give them 5 9s, right? We have to understand, what do our customers actually want? Customers happy with 9 5s? How is that even possible? Well, maybe your service only runs during business hours, Monday through Friday. Do you need 24/7, 5 9s uptime for that service? No. So we have to think about the proper objectives that are going to meet what our customers are looking for. So let's just look at what those might look like here. So provision, we had an availability SLI and a latency SLI. So we might say, for this particular service, for this particular customer journey, this action that the customer is taking, we want 3.5 nines successful in the previous 28 days, and 90% of our requests are served within 5 seconds. Now, this 5 seconds maybe seems long. Remember, what we're doing is provisioning a full suite of applications for this customer. So you have to understand that customer. If this was loading your home page and you set your latency to 5,000 milliseconds to 5 seconds, do you think your customers would visit that home page very often? Probably not, right? So again, we have to understand our customers. The other thing that we might want to look at specifically with latency is if 90% of all requests are served within 5 seconds, maybe we say that's kind of an upper bound. Maybe we expect it to be faster most of the time. So let's say 50% or more, or the 50th percentile, are served or returned within 2 seconds. The other thing that's really important here is that we're looking at a rolling window. We're looking back 28 days. And this is why this is important. We have to understand, what has the customer's experience been over the lifetime or recently? And each day we move forward, that rolling window look back moves forward with us. Sometimes you'll see another acronym that you've heard of, maybe an SLA. You've all heard of SLAs, right? A service level agreement. Now, frankly, we want to avoid those. We want to stay as far away from them as possible because those are business agreements. One of the biggest differences between an SLA and an SLO is this idea of a rolling window. A typical SLA is going to be within a fixed amount of time. So we guarantee you 3 nines of uptime every month. Well, let's say you get to the last day of the month and you have a big outage, and maybe you miss your SLA. So first, maybe that means you're giving your customers money back. But on the first of the next month, guess what happens? It's reset. And how many of your customers are like, well, I just flipped the calendar, so I've reset all of my expectations for that service? Absolutely none of them, right? So these service level objectives follow this rolling window. So in a quick summary about how do you do this, the first thing you have to do is define your problem space. You have to understand who are your customers, and this is a conversation that you need to have with the product owners, with your executives, with leadership. Define that problem space with SLOs and SLIs. Make your system as reliable as it must be, but no more. So each moment when you sit down and decide, what am I going to work on next? This might be, depending on how you work. Maybe you work in sprints. And so there's a planning cycle at the beginning of the sprint. At the beginning of that sprint, check in on your error budgets. Do we have room in our error budgets, or have we already overspent our error budget? If I've overspent it, focus on reliability for this sprint. If I have space to grow, focus on something that's risky. So make your system only as reliable as it needs to be. Error budgets are your primary basis for communication. We have to have shared language with the business, with one another. And through an error budget, we can use this to talk with our product owners about what does that prioritization look like. We can talk with developers to make sure that they're working on the right things. And your SLOs are not set in stone forever. I can guarantee you one thing. If you have no SLIs, SLOs, or error budgets today, and you go back tomorrow and set some, they are wrong. They are wrong. And it's not because I did a terrible job explaining them, because we all know that's not true. But you just haven't experimented with them yet. You haven't tried them out. So over time, just like everything else, you're going to iterate and learn more from these. And the team relationship has to be strong to make this practice work. I have seen teams, operations teams, decide error budgets are the thing. We're going to set SLIs and SLOs, and we're going to do it by ourselves. We're not going to talk to the development team. We're not going to talk to the product owners. And now we've exhausted our error budget, and so people come to us and they want change, and we're like, nah, we're out of error budget. We got to focus on reliability. And no one understands the words that are coming out of your mouth, and they don't care about that. We have to all agree on this together, share our fate, and share this language. If you want to learn more about site reliability engineering, you can check out both of these books online for free. The Site Reliability Engineering book talks about all of the practices, and then the Site Reliability Workbook is great because it's full of exercises and ideas on how do you put those practices to work. And I will close by saying one thing. SRE is something that we do very well at Google. And I'll say another thing. You're not Google, so is this even going to work for you? At Google, we have teams of SREs. I would posit to you that the minimum size for your SRE team is one CFO or one CEO, someone who cares about the reliability of your services. Now, you don't need SREs. You can put these practices into place right now, today. And I'll be around for drinks later, so if you want to talk more about how to do that, please do come see me. Thanks very much.